So yeah, I just want to show you a bunch of features in Scratch that you haven't seen yet. It'll be very interesting, I think. And I don't have a ton of slides because it's just going to be mostly me fiddling around with stuff in Scratch. So let's go. So here's the first thing I want to do. I want to teach you about a block that clones your sprite. You can clone yourself, and that means you can have like a million Scratch cats on the screen, a million fishes on the screen, whatever you want. So I'd like to make a pretty field of stars, and like we'll imagine that we're like inside of a spaceship that's going on warp drive, and the stars are just zooming on past our window. So that's where I want to go with that. So I'd like to make 50 stars in Scratch, all right, with the clone feature. So I'll go to scratch.mit.edu, start creating. And let's see, how do I want to do this? This is the one program where I don't want the Scratch cat. Goodbye, Scratch cat. Are you sure you want to delete this sprite? Yes. I can't even reach the yes right now, so I think I have to add another one to get there. But there's a space backdrop, galaxy or stars, perfect. And then there's a star sprite. Look at it, it's so cute. There's a little star. And now I don't want the Scratch cat anymore. Yes, I do want to delete you, but you're so... It's not helpful. My window is so small. I assume the left side means yes. There we go. Cool. So there's my one star. I would like to make 50 of this. The way you know how is just like, alright, choose another sprite, make another star. No, we will not do it that way. Alright? So we'll keep the one star and we'll ask that star to clone itself. Do you know where the block is for that? Did you see it? It's somewhere here. Probably in looks. Either that or control or events. We'll find it eventually. There's costumes for the star. It's not sound, that's for sure. And it's in control. Yeah, it's in control. So it's like create clone of myself. See that block? So if I click it, there are 2 stars. It just like clones itself on top of the other one. So I click it a couple times. Look at all these stars. There's only one sprite. There's only one star sprite, but it is clone. There's an original one, and then there's the fake ones. There's a clone. If you want to like clear it all out again, you click the stop sign, and then you go back to the original one. You know who was real after that. But that's what I want to do in a loop. I want to make 50 stars. Yeah, I hope that makes sense. So that'll make 50 of them if I do it that way. So when the green flag gets clicked, let's start the program. And I just want to run this block. I want to click it 50 times. Yeah. So I like to repeat 50 times, create a clone of myself. This is a stars program. It's from the stars perspective. So when I click it takes a little bit to do the cloning. It's a big process. But look at now, I have 50 stars. Isn't that cute? I think it's pretty. And they're all on top of each other right now, unfortunately, and that's no fun. So click the stop sign, get back to the original star, the non-imposter. And what I'd like to do is each star, let's have it start out in a random spot. Yeah, because then it'll be like all over the screen. Start out in a random spot with random sizes and directions. I think that would be fun. So when you clone yourself, you're able to wake up and notice that you were a clone. So here's another event. You see it? It's like, when I, as this sprite, when another star begins its life as a clone, do this stuff. So we got the main stars program will just clone itself, and then all the clone stars can run this code. Does that make sense? That'll be cool. So like when every clone begins its life, what I want to do with it, let's have it warp to somewhere random. Go to random position. Don't take any time to do it. So the main star, just sitting here, is going to just like, it's running this code to make copies of itself. It's cloning itself. That's all it's doing. And then every clone is running this code to like go to a random spot. Isn't that cool? It's fun already. Any questions about that so far? All right. So stop sign to get back to the original one. And I want to do more with the clones. So I want the clones to have random sizes and directions too. Okay. So we can mess with those in looks. At least size can be in looks, so set size to be a certain percentage. We'll use the random block in a second there. And then also the direction. Let's make the direction random so that it's not always just like a star pointed a little bit that way. It can be a star pointed anyway. Okay? From 0 to 360, this direction, like make it random. Yeah. And that we can mess with as well. Yeah, it's here. So point in direction, a certain degrees amount. So this one, point in direction. So in any order, this doesn't really matter. This is what I want to do to my stars. When they begin their lives as clones, I'd like to resize them. Let's make the size of the star something random, a random percentage between, I don't know, maybe like 25 and 100%. We'll see if that works for us. And then point in any direction. We don't care about the directions, like from 0 degrees to 360 degrees, whatever you want. Okay? Does that make sense what I'm asking it to do right now? It's just like, it'll be different every time because randomness is like, it'll flip a brand new coin each time. And so I'll get new random effects. Look at them. So some stars are big, some stars are small, and they're all pointed in different directions because of those extra blocks that I just added. I think that's beautiful. Any questions about that? We still there? All right, what's the last thing that I want to do here? Let's have these stars bounce around. Remember that I was asking the Scratch Cat to bounce around by using a forever loop and saying, move in your current direction a certain number of steps, like 10 steps, and then if you're on the edge, bounce off. Those two blocks together in a loop. We can do that for all the clones. So, all right, clones, you're in a good spot now. Now, until the end of time, stars exist for a while, let's have you guys move in your current direction 10 steps, whatever that direction that we just randomly picked for you to go in. And then we want you to eventually bounce off the wall. So here, if I stop sign, rerun it. See how they're running, and then they just hit the walls, and then they just like stay there. That could be a feature, I don't know. But to fix that, you can have this if on edge bounce block right there. Woo, there they go. So yeah, just like move 10 steps, and if you ever hit an edge star, just bounce off so that you're ready to go in the next direction. Look at him go. And this is like a little too much. I don't know. The star shouldn't move that fast, maybe, in a warp drive even. So let's maybe fix that too. I think we can change how fast the stars move by changing the steps amounts. Like maybe move 2 steps every animation frame. That's a bit more, I don't know, leisurely. I think that's prettier. And so we can play around with this. Like move 1 step at a time. Make it super slow. Whatever you'd like to see here. Does not matter. You can change the way the sizing works. Like, okay, maybe it can be 35% to 100%. You come up with the idea and make it happen. Yeah. So this is pretty fun so far. We've got the original star cloning itself, and then all the clones are doing this. They're going to a random spot, picking a random direction to shoot off in, random size, and then they're forever just moving in their current direction, bouncing off if they ever hit the wall of the program. So yeah, it's pretty nice. Are we still good with this code? Any questions about it? Because now I don't like the original star because it's the only one that's stuck there. Right? The original star's program is this one. It's kind of done its job by cloning itself, and then it stops working. It doesn't do anything more. Everybody else, all the clones are running this code, but the original star does not run that same code because it's not a clone. So I think what I'd like to do is once the original star has finished its work, I'll just like hide it because like it's not moving. I just want moving stars. So and also there's 51 stars now technically because I'm like cloning the original one 50 times. So there's the original one is still the 51st. So let's have it hide itself. Okay. Whee. So now it's cloning. There it is still. And now it's gone once it's finished. Okay. Does that make sense? Though, if I rerun this program, I'll have an issue because that star was cloning itself and all of its properties. That star is now hidden, right? That original star is now hidden. So it's now making 50 hidden clones of itself. That's no good. So you can solve that in a number of ways. You can just like make sure that the original star is shown. You can always make sure the clones are shown. Whatever you want. It doesn't really matter as long as you do it some way. But like this just makes sure at the start of the program the original star is shown so that when it makes copies of itself and preserves those properties of it, it itself, all those clones are shown as well. But then it hides itself after it's done. Okay? So there's the original one, not moving, and then it's done its work. It goes bye-bye. So yeah, the clones program is probably the more interesting one. Are we still good? So yeah, just like different ideas together. Just yell at me if you have a question about something. I think the last thing I'd like to do is let's have the smaller stars, right? The stars, things that are smaller, when we look at them with our eyes, are farther away, yeah? So let's pretend that these smaller stars are meant to be farther away, and like there's some atmosphere between us, even though this is open space. And so when you look at things, at least with an atmosphere that are farther away, they get a little blurry, or they're closer to the color of the sky. Well, let's just make the smaller stars more transparent, okay? Just for fun. So if they're farther away, it's like they're harder to look at, and so they'll be like more see-through. That's what I want to do right now. So based on the size of the star, change how transparent it is, okay? And so let's think about this, because I want to, it's going to be this ghost effect, yeah? The ghost effect, and the ghost effect is like a percentage. It's in looks. Such ghost effect to something. It's this guy. Here, if I stop it, let me show it to you on the original stars. Like 0% ghost is fully seen. 50% ghost is 50% transparent. 75% ghost is 75% transparent. It's even harder to see. Yeah, it's a range. It's a percentage. So 0% ghost, not at all invisible. 100% ghost, perfectly invisible. And we would like the smaller stars to be more transparent. So there's like an inverse relationship going on there with the ghost effect. It's like if the size, is this the wrong size of the pen? Let me fix that. If the size of my star sprite, there we go. If the size, let's have an example here. So if the size was 100%, like randomly it was the original size still, then like that's as far up and close as a star could be. So the ghost effect for a size 100 star, I'd like to keep to be 0. Don't make it transparent at all. But like if the size got as small as I made it, it was 35%, then I want the ghost effect to be pretty big. Yeah. So like maybe we'll have this inverse relationship, like 100 minus the size or something, like that could work. So like 35%, make it a little bit bigger, so then it could be like ghost effect equals 65%. We'll have everything in between. So you can kind of do that kind of calculations, like set the ghost effect to be based on your size. Something like this. And you could choose your own calculation. But I think this is kind of the idea that I want to use, like 100% minus how big you are, right? Because if you were large, this will bring it down and make you not very transparent. But if you were small, then your size isn't too big. It keeps the ghost effect amount pretty big. So it's more transparent because it's smaller. Does that make sense? That kind of inverse relationship there. So yeah, that's what I want to build. We have a minus block. We can get our size as a variable always. And that's what I want to do. So let's see here. You can always get your own size right now as a variable. Like right now, the star's size is 100. You can make it even bigger, make it 200% if you wanted to. Or let me just show you that. If you did that, now the size variable changes. So you got a size for every sprite, including the clones. And so I would like to set the ghost effect for every clone to be 100 minus its size. That's what we've determined is a good amount. That means that smaller things would have a bigger ghost effect because they're supposed to be farther away. 100 minus size. And we can put that anywhere, just like up here is probably fine. After the size has been picked, though. That's the order that needs to be like that. So maybe I'll put it next to that. Oh, did I just delete everything? That was fun. Oops. So here, let's put that right there maybe, because they're kind of connected. Like the size, the ghost effect depends on the size. I'll do it like that. All right. So again, the original star is just going to clone itself and hide after it's done. And then all the clones go to a random spot, pick a random size, make themselves as transparent as they need to based on their size, point in a random direction to shoot off in, and then just do it. Shoot off in that direction forever and bounce off walls. Look at them. So the smaller the star is, the more transparent it is. And I think that's pretty. And the bigger stars, of course, are less transparent because 100 minus the size is either 0 or very close to 0. Yeah? Any questions about why this code is doing this? It's calming, right? It's pretty. So yeah, it's different every time because it's random. Click the stop. Do it again. You have a different amount of big stars and small stars, and they start in different positions. So I think that's fun. So yeah, clones. Clones are useful. The original star is cloning itself, then hiding. And then every clone is doing all this, messing with its direction, size, transparency, and then shooting off forever, bouncing off walls. Yeah, this is fun to play around with. I'll give this to you. Save. Are we ready for a completely different example? All right, I'd like to improve now upon my example that was about ghosts. So like, do you believe in ghosts? And then it appears, the ghosts appear if you say that you believe. I did not like the way that we were doing things before, because what we were doing before was we were having a variable, right, that should show ghosts variable, and every ghost was just until the end of time in a forever loop, just keeping on watching that value of that variable. Like, is it a 1, is it a 0? Even though it's only ever going to change once. So it's kind of inefficient for it to just like every nanosecond keep checking that variable. That's all we knew how to do. There's a better way, all right? So it has to do with what's called message passing. This is a pretty complicated idea, but it's easy in Scratch at least. In every other language it's a little weird, but in Scratch it's nice. It's called message passing, and what it means is kind of what the metaphor implies. It's that you can ask sprites to talk to each other, to send them little snippets of messages, and each message can mean something for your program specifically. So there's a concept of a sender of a message, and then people who are listening to hear that message. Whee! So here's kind of what I want to do. There's a sender, there's a bunch of listeners, if I can spell listener, listener. So let's say that it's the Scratch Cat, right, that's shouting out, or here we are, we're saying if we believe in ghosts or not. Let's have the Scratch Cat be involved with the sending of messages. If you remember the program, at least. The Scratch Cat will be involved with the sending of messages, and then the skeleton, the ghost, and the bat can be listening for the message. All right, so let me get the setup again in the code, and then we'll talk about what I mean here. Ghost, and then the bat. Those will be the listeners. So here, I'll keep the Scratch Cat this time. And then, what was it? It was the woods backdrop, right? Scary woods. And Scratch Cat was down here. And there was a ghost. There was a skeleton. And then there was a bat. Those are the 3 scariest things I could find. You could also make your own sprites, though. There's the bat. Beautiful. Scary. So there they are. And let's see, what do I want to do? So remember the setup of the program? It was when the green flag gets clicked, the Scratch Cat asks, do you believe in ghosts? To you, I guess. Do you believe in ghosts? And wait. And all the ghosts were hidden, but then they woke up depending on your answer. Is that coming back to us? And then they were just like, they kept on watching a variable that we made, the should show ghosts variable. And I thought that was inefficient. So there's a better way here. We can do message passing. Let's have the Scratch Cat be able to shout out to the world, hey, the user believes in ghosts, or hey, the user does not believe in ghosts. And then all the scary ghosts can be listening for that message. It's like we're sending it a little message, postmarked, stamped. We're shouting out to anybody who wants to listen, and all the ghosts will be listening. That's the metaphor. And so essentially, a message being sent is another event, and it will wake up the ghosts, and it will let everything work without having to use loops. All right, so we can make a message that means show the ghosts, and a message that means hide the ghosts. Okay, let me show you where that is. That is somewhere over here, probably in events, because a message is like an event. Do you see these? Broadcast, when I receive a certain message. Yeah? So this is like a default message. I don't think I can right-click to rename it even. But let's make some new messages to receive and to send. So I'll call it show ghosts. And I'll also make just in any of these, you just like click it down, say new message, and a hide ghosts message. So now, you see what you can do? It's like, if the user believes, you say broadcast show ghosts. It's like shout that out. And if the user does not believe, you broadcast hide ghosts. Does that make sense? And then everybody else, all these ghosts, can be listening because they have this block right here. They have this, when I receive the hide ghost message, do something. When I receive the show ghost message, like wake up and do something. So it's just they're looking for the message. They're not having to be in an infinite loop waiting to see if something changes. It's just like they wake up if something gets shouted out to them that they understand how to process. So that's the setup. Are there any questions about that? I think it'll be cleaner than last time. So let's try this. So, all right, here's kind of what I want to do. Ask, do you believe in ghosts, and wait, and then based on the answer, I guess before the answer even starts, tell the ghosts to hide themselves. Shout out, hey ghost, hide yourself, right? Because we're not sure if they believe or not. Then ask if you believe in ghosts, and wait. And then based on the answer, if answer was yes, if answer equals yes, tell the ghosts to, hey, come out. Otherwise, you can tell them to stay hidden. Just like, keep yourselves not shown. Broadcast hide ghosts after that. So something like that. See how it's shouting out, like, all right, hide yourselves at the start. And then, depending on the answer, then you can say, okay, ghosts, show yourselves, we're ready. Otherwise, keep them hidden. And then the ghosts are going to hook into both of these and just wake up. Like, from the ghost perspective, this is the ghost program right now. When it receives the hide ghost message, what should it do? What do we think? It's going to wake up, notice that it's been asked to do something. What is the one block I should put in there? Are we confused or are we shy? I need to know. I'm just going to stand here until you tell me one or the other. Yeah. Yeah, that's all they need to do, right? If somebody asks them to show themselves, all they need to do is run their show block. If somebody asks them to hide themselves, all they need to do is run their hide block. Good, thank you. I appreciate your response. All right, yeah, so does that make sense to us? It's like, all right, somebody's asking me, like, I'm being commanded right now to hide myself. There's my block that I need to run. That's the only one I need to run. Do you have any questions about that? Or are we just shy today? We're tired. That's all right. All right, so that's what's going to happen. So with the ghost now, watch. I'll click the green flag, and then the very first thing that happens is the hide ghost gets broadcast. Click. Do you see how the ghost, that's the only one who was hooking into this stuff right now, it ran the block because it received the message. It was listening for it. And then if we say, yes, we believe in the ghost, then it's going to run the show ghosts message. It's going to shout it out. And then the ghost was also hooking into that, listening for it. It's like, all right, I will show myself. I have been commanded. Isn't that cool? I think that's much more clean than the other one. Like, we've just gotten rid of an entire variable and then also a loop that was running forever, which was very inefficient. These are just like waking up when they need to wake up. This is perfect, right? And so everybody else needs these. Give it to the skeleton. Give it to the bat. Both of those guys. And they're right on top of each other. So yeah, everybody, just like all the ghosts, all they need to do is like know what to do when a command has been given to them. It's like if somebody shouts out, show myself, show the ghosts. I'm a ghost, I will show myself. If somebody shouts out, hide all the ghosts, I'm a ghost, so I better hide myself. So all three of these guys have the same programs. They're hooking into the same messages. And then the Scratch Cat is like the orchestrator of the show. All right. At the very start, hide ghosts. This got run. Everybody's listening. Do you believe in ghosts? Yes. They all wake up because they're listening to that show ghosts message that got passed to all of them. That got shouted out to all of them. I think that's neat. Questions about that? This is slightly inefficient, though, because we don't really even need this else. Does that make sense? Because like at the very start of this code, we tell all the ghosts to hide themselves anyway. It's just like if the answer is yes, now show yourself. You're already hidden. You don't have to tell them to hide it anymore because at this point, they were already hidden by the time we get here. Does that make sense? It was already hidden, so we actually don't even need the else. You can use just the if, because you only just want to do something if it's true. Just do nothing if it's false. You could have an empty body if you wanted to. So like even if you said no, they stay hidden. Just do nothing at all. Like this will work, but there's a cleaner way to do this. It's just do the if only. So let's steal that, and that, and that, and then that's unnecessary. And so that's as short as I think I can make it. There we go. It's like, only if the answer is yes. You're already hidden otherwise. Show yourself. Yes. Look at them wake up. And if I say no, it's just like nothing happens. They stay hidden. I've not told them to like come out of hiding. Okay? So that is message passing in a nutshell. Questions about this? All right, I like it. So, yeah, let me give you this code. I'll give you some time. Here's the code, just copy it again. Mostly the same. Let me take the new stuff though. This is from last semester. And this is what we did. We did that one. If you haven't had it all, got it already, and this is the message receiving and being commanded stuff for the ghosts. So here's both of those, and I just like to give you some time to play around now. All right, so you can hook into these messages and do other things. I think that would be useful. So try to recreate this. I'll give you some time to just play around, make it cool. Try to change it, right? Make all the ghosts say boo when they come out. Make them all like fly around. Make them transparent. Remember how to make them flicker like I did last time. See if you can remember that. I'll help you. You can make a new message, like maybe like respond to the answer of maybe or something. Like maybe I believe in the ghost, and then half the ghosts show up or something. But yeah, play around. That's the best way to learn. And there is time for that. All right, I'll come around and help if you have any questions. But just take a few minutes to like work on this. Try some cool stuff. Show your neighbors how cool your programs are, and then we'll come back. Okay? And I'll be here if you have questions. Maybe you can make the scratch cat fight the ghosts if they appear. Nice, they're saying too. I'll give you another couple minutes because it looks cool. The things you guys are doing looked cool, and we'll come back. I believe that was my timer. Any questions that came up as we were trying this? It looks cool what you guys are doing, so there will be plenty more time for that in just a little bit, all right? I think the last real thing I want to do today before I let you just like hang out and do other cool things is I'd like to make another game for us. I'd like to make the Pong game. So, do we all know what Pong is, first of all? It's like one of the original video games. It is very old now, but like it started it all kind of. It was a game where, I guess it was a two-player game, really. It's meant to be like ping pong inside of a computer, or like tennis. So you got like a little paddle. There was two paddles, and then there was like a ball that was bouncing around, and your job was just like to hit the ball back and forth, and whoever like let the ball past them lost. So what I want to do is make a one-player Pong, or like the ball comes in, you hit it, and it just bounces around on the screen until you lose. One player is easier than two players. Maybe you can make it two players after I show you the one player way. Yeah. So let's make that happen. So we're gonna need a new window with a paddle and a ball and just like space to jump around it. Okay. So did I save this already? I did not. So here, let me save what I have, and then I'll clear it all out. And this is another program where we don't need the scratch cat. So sorry, scratch cat. What I would like is, you can pick whatever backdrop you like, but there's a ball sprite, and then there is also a paddle sprite somewhere. Paddle. Though the paddle is going the wrong way right now. We can fix that with the direction. We can give it like direction 0, or 180 would work. It's kind of a small paddle. Maybe it makes the game harder that way, but I can change its size to be like 150%. Maybe that's a better size paddle. I don't know. Whatever you want. You can deal with that. But these are the two pieces, aren't they? You got the paddle, you got the ball. Now, I want the paddle to be able to move up and down. Yeah, I would absolutely like that to happen right now. So we could mess with keys and be like, when the up arrow gets pressed, when the down arrow gets pressed, like change the Y, change Y by 10, change Y by, the up means negative Y, right? No, up means positive Y, down means negative Y. Like that would work. Whee! But I want to show you other things. So here, instead of doing it this way, and using the keyboard to move the paddle, some like websites do this already. Maybe you've seen it before, like you've played a game that's like this. Let's have the paddle follow our mouse. I'll just move the mouse up and down. That's easier for most of us to make precise movement, right? That's what mouses are for. So let's have the paddle follow the mouse pointer. There's a way to hook in to where the mouse is right now, and I forget where that is. There's a variable somewhere. There's a couple of them. There it is. It's in sensing. You can get the current X and Y coordinates of your mouse on the screen at least. So I got to move it. I got to be on the screen for it to be at all useful. But I can hook into where my mouse is right now, is what I'm trying to say. Does that make sense? Bless you. So here, let's, when the green flag gets clicked, what I'd like to do is forever have the paddle follow the mouse pointer. Because like it changes every split second. Like forever, keep hooking in to whatever the mouse X and mouse Y currently is. So it'll change as I move my mouse. It'll always be set to where my mouse is on the screen, the coordinates of it. Please always go to wherever the mouse is. Go to the mouse X, go to the mouse Y. Does that make sense? Forever until the end of time. Keep running this. Green flag. And look at it. It's following my mouse, the paddle. It's like forever, every split second it updates. The mouse X and mouse Y variables update. And like if my paddle, or if my mouse is at 127.30, it moves the paddle. Because that's where the mouse is. It has those variables. It hooks into them. That's pretty neat. Any questions about that? I like that a lot. This is not how Pong paddle should work though, right? Stop. Move it back. It should only be moving up and down. We should never be changing the X, right, of the paddle. It should just be saved as whatever it started out as. Like this was negative 202. That's where I put it. So instead of this, I don't want to mess with the X error. I just want to mess with the Y. All right. So that's what I want. Set Y to the mouse Y. I do not care about the mouse X. The mouse X is over here. Just take the Y part of it. Mouse X is over here. Just take the Y part of it. I don't care about the X. You see how now my mouse is way over here? It's only the Y direction, the Y coordinate of it, that's being placed anywhere. Any questions about that? That's pretty neat. We get it? I like that. So that's the paddle. That's settled. Cool. Then we need the ball to like move. Yeah, the ball needs to bounce. So let's give the ball, I don't know, a random position and a random direction. I think that would work, just like the stars. So we'll give the ball, when the green flag gets clicked and the game begins, we'll give it, just like we were doing for the star field, we'll give it a random direction and a random, I guess that's all we need. Random direction, keep the same size, and then just forever bounce off. So pick a random direction from 0 to 360 degrees to start off in, and then forever keep moving that way. Please, ball. Forever keep moving in your current direction, and then bounce off the walls if you ever hit a wall. Just like for the stars. So that's the balls program. It's random, so sometimes you get a very unfortunate game there. That's a better direction to bounce off in. But right now, of course, it's not hooking in to the paddle. And that's the last real piece of the puzzle. Though also, do you see how sometimes if I start the game and the paddle's not in the right spot, due to randomness, let's see if I can get it to happen again. Due to randomness, oh no, sorry, yeah, I did forget one thing. I want to start at a random spot, excuse me. It's like, go to random position, please, ball. And now it's like different every time, different every time, different every time. Whee! So it starts in a random direction, it starts in a random spot, and also starts in a random direction. It may be the case, though, now, thanks to that first block, that the game just starts, and it's immediately over because it randomly spawns right here with the direction of that way. Does that make sense? We would like to have the user have a chance, so can I get that to happen? Yeah, so like right there, I would have lost the game. So let's make sure that the game is always winnable. I think what we could do is force the ball to begin its life on the right side of the screen. We just did that, no matter the direction. Then we're good. So don't go to a completely random position. Make a random position where like the x is always positive. Then the y could be whatever you want. Just like make sure it's on the right side where the x is positive, because x is negative would be like an unwinnable game maybe if we got the wrong direction. Yeah. So yeah, let's have it do exactly that. Go to a random position. Maybe let's just do two of them. One set x and one set y. You could have done it all together, but it's easier this way. So let's have set x to be something that is never negative. So like 1, 2, what's the biggest this could be? 253? It doesn't matter. Let's do it to 250. And then y can be whatever it wants. It can be down here, negative 170, positive 170. Do you see how now, even with the randomness, I've kind of controlled where the ball is going to be. It's going to be on the right half of the screen because of this first one. X can't be negative. See it? So now, no matter what, no matter the initial direction, the ball is going to pick a random y, but a constrained random x. It's always going to be on the right half of that screen. It will never be close to the paddle. So there's always a chance to win. Okay? Does this make sense still? Questions about this so far? All right. So now we just need to hook in the ball to the paddle. That's a huge, huge bit, right? Boop, just like that. So I guess what we can be doing is we can let the ball deal with that because it's already dealing with, like, if I'm on the edge, bounce and move a little bit. Let's just have it, like, if it hits the paddle, bounce. Because it's from the ball's perspective, right? This is the ball's program. It's like if I'm on the edge, I bounce. And also if I hit the paddle, I bounce. Yes? So how do we know, first of all, when the ball has hit the paddle? Do we remember? Like how? Is there a way to check if the ball has hit the paddle? Wait, remember what I showed you to do it? You remember the name of it? It's somewhere in the blue section, yeah? Something pointy is this one. Touching, yeah? So is, if I move them out, it's always from the perspective of the current sprite, so like paddle. Is the ball touching the paddle right now? False. Is the ball touching the paddle right now? True. So that's what I want to hook into. So if, it's going to be an if. On edge bounce, and then also if I'm touching the paddle, I want to bounce off. So that kind of makes sense what I want to do there. So if the ball is touching the paddle, how do I want to deal with this? The real way to do it would be something like this. The ball, if the ball is coming in this way, it should be bouncing off like that way. There's a calculation that you could do. I encourage you to think of what the calculation should be. I'm going to show it to you, not today, but later. Just to keep it easy on ourselves, let's say that if the ball comes in this way, we'll just bounce it off. and have it do a complete 180, which is not how it should be in real life, but that's okay. Try to do it the right way, if you can. You can think of it. It's supposed to bounce off that way, really. But we'll just have it do a 180 if it ever hits the paddle. So that's all we need to do in the body here. So if the ball is touching the paddle that ever happens, keep checking all these things, right? Keep moving a little bit, checking if we're on the edge, bounce, and then also if we hit the paddle, also bounce, okay? So if we touch the paddle, then ball shoot off at a 180. So that is, you can turn left or right at a 180 because it's the same direction at that point, right? So I'll just say right. You could have said turn left 180. It does not matter. That'll turn it off at a 180 degree. Whee! And so, with that in mind, it's like always checking, always moving a little bit, checking if it's on the edge, bouncing. And now if it ever hits the paddle, it will also bounce. Yay! I love it. That's pretty satisfying. Are there any questions about this so far? Do you see what the ball is doing? The ball has the hard part. The paddle is just dealing with following the mouse. Then the ball just keeps on moving a little bit, checking if it's on the edge, bouncing off if it is. And then also, if it's ever touching the paddle, it will bounce. Do the 180. Both of these will never usually be true, right? It's just like either you're on the edge or you hit the paddle, or it's just like empty space. Keep moving. I think that's very satisfying. Do we get it? Are there questions about this, kid? Could you do this yourself? If I hid the code from you? And it's different every time. It bounces off at a different rate, or same rate, just different direction, different starting point. And I think that's fun. So yeah, that's the balls program doing all that. And then the paddles program was just very simple, right? It just keeps on following the mouse pointer till the end of time. But yeah, the forever loop is very important. Just like every little split second, keep checking, keep moving the ball a little bit. Checking. Did I hit the edge? If so, bounce. Yes. So like there, it would notice and bounce. And then also keep checking every little bit. Do I hit the paddle? Yes. If so, change my direction to bounce. Okay. That's what's going on there. And I think that's what I wanted to say there. There's one last step to Pong, right? We need to be able to lose the game. So like if you're too slow, then it gets to the left side and you've lost the game. Okay. You could. There's a couple ways to check for that. You could be checking the X of the ball, right? Because there's a point at which the X got so small that it passed the X of the paddle. That's one way to notice. That would work. Just add another if. And a simpler way to notice would be just to add another sprite. There's a line sprite that we could turn and just put right here, and that will be the boundary line. And now just like if the ball ever touches that line, the game is over. Does that make sense? That's the easier way to do it. That will be how I do it then. So here, let's see what I want. Let's do this. Let's be in the lines program now. The line can be in charge of noticing if the game is over or not. Yeah? So yeah, let's do that. Let's do when the game starts, the line is, from the line's perspective, it just wants to know, is the ball ever hitting me? Because if so, that means it got past the paddle. All right? So, just like forever, until the end of time, keep checking every split second because the ball's moving every split second. Keep checking to see if the ball has hit me. If I am touching the ball right now, boop, this is from the current sprite's perspective. So if, from the line's perspective, I am touching the ball right now it's false. But if we ever let it pass, it will be true. We go over there. If that ever happens, then it's game over. Does that make sense? That's what I want. So to make game over, we kind of want to just like press the stop button. There is a block that presses the stop button for us. It's in control. It's this one. It's called stop, and like you say all. We want to stop everybody. And notice how like every other block, where is it? Every other block, like wait, has a little place to hook into other things below it. I love the way they did this in Scratch. Do you see how that it's just flat on the bottom for stop? Which implies you can't put anything below it because the program stopped at that point. I love that they did that. That's so cool. So this has to be the last thing. It's going to stop the program, stop the game. Nothing can go below it. It is the end of everything. Okay, so that is the lines program now. Forever, it's going to keep checking to see if the ball has hit it. If so, it will stop the game. It's like, it's not touching yet, it's not touching yet, it's not touching yet, it's still not touching. And then if we let it, boop, it presses the stop button for us. I love that. Are there any questions about what's going on here? Are we getting it? So yeah, this is fun to play around with. I encourage you to try to make a 2-player version of this. Like maybe one can use the mouse, one can use the keyboard, or like both can use different keys on the keyboard. It's up to you, but I think it's fun. For my last trick, I would like to just like have a little banner, just like every other game does, like game over, you lose, something like that. All right, and we'll do that. We'll make a custom you lose sprite, and we'll have it be displayed with a message. How about that? That gets displayed via a message. I think that will be fun. All right, so let's make a sprite that will be appearing when like the game is over. I don't want to choose a sprite. Sorry, I was supposed to go to the paint one. So if you go to the paint one, you can make your own sprite. You can add text. Be like, you lose, sad face. You can make this as big as you want. Something like that. And like that's our sprite now. Okay, that can be our sprite. And you can give it a name. You're in the costume section right now. Once you're done making your sprite, you go back to the code section. And you can call it, I don't know, call it you lose. I don't know. Whatever sprite name you want to give it. And like, that is now a sprite that you can hide or show. I want to show it when the game is over. Yeah, that's what I want. So, I think we can play the ghost game here and say game over as a message. And this can be hooking into that message. So here, let's go down, or I guess I'm already here in events. Let's make a game over message. Game over message. Yeah. And then we can have the you lose sprite be hooking into that. So when the program begins, the game is not over. So make sure the sprite is hidden. Game's not over yet. But if somebody ever shouts out to me that the game is over, the message game over, then it's my time to shine as the you lose sprite. I will show myself. See it? So who notices now that the game is over? Who gets to shout it out? It's the line sprite, right? That's the one that's going to stop everything. So right before it stops everything, have the line shout out to the world, hey, the game is over. Broadcast. The you lose sprite will show itself at that point, and then it stops everybody. Does that make sense? What's happening there? That's pretty clean. It's better than like using a variable to keep track of that. Just like have a message. That's perfect. So yeah, at the beginning of time, the you lose sprite is hidden. But the second the game is over, it shows itself because it received that message from the line who's like, oh yeah, I noticed that the game's over. I'm going to shout that to the world. Anybody who wants to listen and do something based on that can do something. And the you lose sprite's like, I'm ready. Let's go. I think that's fun. Are there any questions about that? Just like it restarts. And it's going to do it. It's going to do it as long as we lose. So if we're good at this game, we can keep playing forever. But eventually, give up. And it ends. Yeah. So yeah, let me just walk through all the code, and we'll go from there. I think the paddle is the easiest one. Just like when the game starts, the paddle is just following the mouse forever. There's a mouse Y variable that you can hook into. That's always the coordinate of the mouse for the Y direction, and that gives us up and down motion. That's perfect. The ball was probably the fanciest sprite here. The ball needs to start off on the right side of the screen. Yeah, random X, but positive only. And then anywhere, top or bottom. And then point it in a random direction, like shoot off that way, whatever you want. And then, until the end of time, until the game is over, the ball should be moving a little bit, a little chunk of steps, 10 steps in your current direction. And then if you're ever on the edge, bounce. And then if you're ever touching the paddle, also got to bounce off. So we program touching the paddle and bouncing as this check and then doing a 180. Try to think about how to make it do the right things. Like if it's coming in this way, it should bounce off that way. It's not a 180, actually. Try to think about the math involved there. I'll eventually show you that answer. And yeah, that's what the ball was doing just forever until the end of time, until the game's over. And then the line was our 2D way of checking if the game was over. So like if the ball ever touches that, it must have gotten past the paddle. And so like forever, just keep checking. If the ball is touching me right now, the line now, then shout out that the game is over. Anybody who wants to hook into that can do it, and then stop the program, stop everybody. And then the line, almost as simple as the paddle, it's like when the game starts, like the game's not over, so don't show myself. But when the game is over, when I receive that message that the game is over, I better come alive, okay? So I think that is everything that I wanted to show you for Pong. Are there any questions about all that? I'll give you this code. All right, so here, let me save it so you have it. I think that was fun. And yeah, that's all the slides that I have for the day. The last thing I want to do is give you your next programming assignment. This will be due in a couple weeks. So you got some time to do it. And this will be you making a game. All right, if you're doing the Scratch assignments, you'll make a game, okay? So what I'd like you to do, if you're doing the Scratch assignments and you've never programmed until this class, I'd like you to follow along with this dude's lesson. All right, so he has made a Space Invaders game for you. You will follow his lead. You'll just follow along. You can make it as fancy as you like, but the Space Invaders game, you'll have a little rocket or like cannon at the bottom, and you can shoot up things at the aliens. And I don't know if I can get it to display the actual game being played. Yeah, so it's like there's falling tacos apparently, and you shoot the tacos. That's how he did it. So you're welcome to do it that way, but I just want you to make Space Invaders. All right, so follow along with that video. Where is that? Go. There you go. And you can change it as much as you want as long as you do everything. So just like follow along and make a fun game. You can make different things that you shout out to, okay? So yeah, what I want you to do is get that working. Make whatever enemy you would like. You can shoot ghosts if you want. And then upload a video. Upload a video of your program running. Talk to me about it. Make sure that you understand it. I'd be happy to help you if you're confused about why he did something in the video. Like you don't understand why it's working, but there's going to be clones involved. You're going to clone the enemies and stuff. It's going to be very cool. And yeah, I just want to hear you talk about it for a little bit. Just like, it doesn't have to be long. Here's the code. This part's doing this. This is the most interesting part, whatever. It can be a 1-minute video. I don't care. All right, as long as you just prove to me that you understand it. All right, so that's your program if you're doing the Scratch assignments. Are there any questions about that? I think that'll be fun. And then if you're doing the racket assignments, let me know again if you want to do something custom. But this is your job. Read these sections of the book and do these exercises. And just like the others, please record a video, show to me that you understand the code, talk it through to me, and that's pretty much it. All right, so that's your assignment. Are there any questions about either of those? That'll be due week 7, so a couple weeks from now. February 27th. Looks like 2 weeks and 1 day from now. We good with that? All right. I think that's all that I have. So the rest of the time is all yours to work on things, make your cool Ghost and Pong games, and ask me lots of questions.